So, what will be controlling these quadrant objects? Another object. In our case, the main bone of our character, but in this scene it's going to be an object that's called main, which represents the main bone of the character. We go into setup and just drop a cube into the scene. I'm going to make sure this cube is outside of the hierarchy and name this the same as our bone that's going to be in our character, main. Just move him out of the way. Now this main object is going to use its heading to tell us what quadrant the animations are going to be in. How do we control that translation with a rotation from our main object? What useful values does rotation give us? In Messiah, everything translate is in meters. Everything rotate is measured in radians, even though the motion block shows us degrees. So what's a radian? Well, it's the mathematical measure of angle. Yeah, degrees are angles too, but it's easier to calculate with radians. Here's an example. Let's create a new variable and call it direction in the command tab. New variable, double click on that, direction. Let's load a heading of our main object in here in the expressions tab. Just left click to load it into the buffer, main underscore heading. Right click, so now we're looking at heading. Turn on debug and you can see as we rotate heading here, if we are at 0 degrees, we should be near 0. And when we rotate our heading to 90 degrees, we get what looks like 1.5. So if we rotate this 180 degrees, take a look at the numbers now. 3.141, that's pi. So pi rotates things 180 degrees inside Messiah, which means for a full 360 degree rotation, you go 2 pi. So we get to the old high school math here, where 2 pi equals 360 degrees. So the goal of looking at radians here is to try and create a range as we rotate 90 degrees that we rotate 1 unit's worth of a rotation. So how do we get pi, which is this 1.5 number, to be a 0 to 1 when we're facing forward versus when we're facing sideways? Well, if we have 2 pi, then what if we just did a divide by, and then parentheses here, pi divided by 2. So that'll cut pi in half, and then as we divide heading as well, we should see as we rotate to 90 degrees, we have a value of 1. So what that means is when it's aiming to the right, if we took that value of 1 and put it into, say, the translate, this would translate out to a value of 1. As this rotated back down to the 0 angle, this value of 1 would fade back down to 0. So we get a decent way of normalizing these values. Normalizing means we just stuff it into a range that we can understand, 0 to 1. So here's 0 to 1. 0 to 1 is 1 unit. If we go facing backwards, that's 2 units. Well, let's work on that on the next video. But if we go back to 0 and aim the other way, we get -1, and then we get -2. So we have a range of -2 to +2, but each quadrant gets 1 unit's worth of this rotation. So that's the first problem solved. The second problem, well, what if we go over 180 degrees? We go to 180 degrees, it's unit 2, and we continue back on to 360, and now our direction says 4, and then 5, 6, and we can do that the opposite way as well as we count down. Well, how do we get that so that we're aiming here, we just want this to show -1 if we're aiming to the left, and we want it to show +1 if we're aiming to the right, no matter how many rotations our controller has made. Well, this is where another equation comes in, and it's called EP wrap pi. Pi, in rotations, once it hits 360, should start at 1 again. So down here at the bottom, EP wrap pi, you take a look, it looks like there's this weird field called theta. Just ignore that for right now. This is going to get copy, paste, theta main heading. Add a new one in here, and then divide, use our special normalizing function here, in parentheses, pi divided by 2, so that we can push all of these values back down into the 1 unit per 90 degree range. So now as we rotate to 1, then we go to the end here, we rotate to 2, oh, and then once we cross over that 180 degree threshold, it immediately slips to -2, counts down to -1 and then back down to 0. So no matter how many times we rotate heading, if you take a look at the angles keep going up, but it keeps counting in our range of 0, 1, 2, -2, 1, 0. So that's how we can wrap pi. So that's the final equation for figuring out how we're going to convert heading into a translation value where we can translate single units. So our total range for all 4 quadrants is -2 to +2 within the variable. No matter how many times we rotate, the value coming out of the direction variable is still within that range of -to +2. Going to animate, I'm just going to set these angles back to 0. We have our command, so file, and just save the scene again and overwrite.